Welcome to 100 days 100 questions coding challenge. In this series we will cover all the frequently asked interview questions. Today is the day 1 and the problem statement is write a program to complement all zeros and ones in a number. Label is easy and concept is called recursion. So a function when it called itself is called as recursion. Like this is the function, it is calling itself, hence it is a recursive function. So let's suppose we have the input, and for this input if we see the corresponding output should be output should be 0 3 1 1 3 0. Okay, how we will get via recursion? So this is the input to our function, so we will break it into two parts. First we will divide mod it by 10. So the same input mod 10, input mod 10, this will give as a remainder value 1, and the same input we will divide by 10, input divide by 10. This will give the dividend which will be the input toward the next iteration, or when the next function calls itself next time we will give this value as a input. Then further it will got divided into two parts. This part will go as a remainder and this part will go the input to the next function. Then again we will divide it into two parts. This part will go as a remainder and the dividend will go as a input. Now 130 will further divide it into two parts. Remainder will be 0 and the next input will be 13. Now 13 will be further divided as a remainder 13 and input to the next function call will be 1. Now we reach the termination condition. Termination condition is very important in the recursion problem. Otherwise your function will run on indefinitely. So when input will be 1, your remainder will be 1, because input mod 10, your remainder will be 1, but 1 when divided by 10 your dividend will be 0. So from previous one the function return, which is we represent as a result, return is 0. So result as a 0. Now in this result how we will calculate the next result? The formula we have used is the next result is equal to previous result or previous return value into 10 plus if remainder is, if your remainder is 0 or 1, then we will take its complement. Okay, else we will go for next result will be result or previous result into 10 plus your remainder as it is. So in this case your result, which is 0 into 10 plus complement of your remainder 1, which will come as a 0. So 0 into 10 plus 0 is 0, which is your result. Now your this result 0 into 10, since it is not 0 or 1, so we will keep remainder as it is. So we will get what? 3, which is your next result, or return to the function which is will give as a next result. So now next step is 3 into 10 plus complement of your remainder, which will give as a 1. So it will be total as a 31, which will be your next result. So 31 into 10 plus complement of your 0, which will be 1. Now it will be 3, 1 and 1. Here you will get the same result. Now similarly 3, 1, 1 into 10 plus, since it is not 0 or 1, we will keep as it is. We will get as a 3, 1, 1, 3. Now final last step, 3, 1, 1, 3 into 10 plus, since it is 1, so its complement will be 0. So it will be 3, 1, 1, 3, 0. Is it the same? Yes. This is our final output, what we were expecting. Now moving on to the coding part. So this is the coding part. First we will make a recursive function. So int, which is the return data type, function definition, replace argument data type, and the argument is, as I told, the most important condition is the stopping condition. In the slides we were seeing that it was stopping when the input become 0, and when the input becomes 0 we were making result as a 0 and returning the result. Return result. Now the stopping condition is ready. So what else to the stopping condition? Now we will write the body of the program here. Okay, so we have used the result, but we haven't declared the result. So declaring int result. In the body we will write as remainder is equal to num mod 10, because what we are doing, we are finding the remainder by num mod 10, and we were dividend we are passing as a argument to the next function. So num is equal to num divided by 10, and pass it as a resu result. Call the same function with the new argument and modified argument. So recursive function is almost ready. Now if your remainder is 0, or if your remainder is 1, then we have to complement. Result is equal to previous result into 10 plus complement of remainder, else result is equal to result into 10 and the remainder will be as it is. Till here it's fine. Now after this we will return the result. Return result. In the mean, we will first, let's say input A is equal to, we will say take the same input as we took in the slide 130031. We can take differently and it will work. Printf, so it will print result percentage d. Since the result type is integer, so we will write the percentage d. So function is replace and pass a as a argument. Now I guess it will work. Run. Is there any problem? Yes, we haven't declared the remainder. So remainder, sorry, I'm declaring at the wrong place. Here it will be declared remainder. Yeah, see, the output is ready. So 1 complement is 0. It is not coming in the result because 0 is automatically discarded. So 3, 3, zeros complement 1, zeros complement 1, 3 as it is, and 1's complement 0. So our code is successful. Instead of this, if we try with another example like 4 1 5 0 3 0, let's check with that. It's working. See, 4 4, 1's complement 0, 5 as it is, 0's complement 1, 3's complement, this 3 doesn't require any complement, again 0's complement 1. So our code is working fine.